Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So on the workbench this week is something that I made quite some time ago, probably 8 years ago, maybe even 9. It was before I had a 3D printer, but I actually remember making this thinking to myself, you should really check out those 3D printers because they're probably great tools for making these types of things. And yeah, I mean, I got one and the rest is history. I hardly ever make stuff in janky ways like I did this back then. Now what this is actually a square drive wrench, and it has a very specific purpose. The part down here at the end is actually, this whole thing is constructed from a piece of PVC pipe and 2 pieces of plywood and a solid hunk of aluminum rod that just goes through 2 holes that are drilled in the end of this. It's hollow here inside. And the 2 pieces of plywood, one of them is basically a backer. It's just a piece that is cut round as a plug. And then the other one I cut as square as I could, I think with a jigsaw. And then I used a file or a wood rasp in the corners. And this wrench is to put in the drain plugs in the skimmer baskets for my pool. When we got the pool put in, we had it, we paid people to close it the first year, and I basically just took notes and watched what they did. And every year since, I have just opened and closed the pool myself. But they had this long-handled wrench that they used to put the drain plugs in the skimmer baskets. And I watched them put them in, and I thought, man, I'm going to need to get one of those wrenches or I'm never going to get them out. I'll find a picture. My pool's closed now and the cover's over it, so I can't walk you out and show you my pool. But I will find a picture of one of these like skimmer sumps and put it here on the screen. You should be looking at it now. And the issue is the drain plug is all the way at the edge of the skimmer basket. So let me find something that's about the same shape, and I can show you here better on the bench. All right, this bucket is actually a halfway decent analog. So imagine there is 2 different drain plugs in the bottom of this, and they're both right up basically against the side of the bucket. And this goes down, this bucket is, imagine this is about 3 times as deep as this bucket. And the drain plug is all the way at the edge of the bucket. So you can't use anything with a wider diameter than about the diameter of this pipe, because it's right up against the end and it is way down in there. And there's not enough room to get an adjustable wrench in here. You could get a really tiny adjustable wrench, but that adjustable wrench is not going to open up to the size of this square drive. I think this is 1.25 inches, but we're going to measure it. So I made this up, and I made this up because to buy one was, I want to say like 85 bucks, which is not the end of the world, but 85 bucks just seems like a lot to be able to take off a pipe plug. All right, so why are we here if I already made one of these? Well, 3 reasons. Number 1, this one is actually slowly starting to fail. My pool is a saltwater pool, and it is eating the small nails that I use to secure this in place. I didn't want the PVC pipe to break out. So I drilled small holes and I put very small nails in, and those nails go into the plywood here at the end. And then I masked this off and I spray painted the whole thing with several layers, several coats of this, gray, glossy spray paint. And you can see it did protect it for the first couple of years I used it, but every year it gets a little bit more rusty. And I know one year I'm going to go to use this and the plug is just going to twist in here, and I'm going to be stuck until I go make one, which is a real pain because opening or closing the pool is like a several-hour process, and it's not easy to stop in the middle of it. So the last thing I want to do is wait until this tool fails to make another one. Second reason is I knew it would make a good video to make one of these. Ever since I got the 3D printer, I've been thinking about remaking this. And number 3, I figure there's got to be somebody watching this video that has the same problem and is thinking, gosh, I don't want to pony up the 80 some bucks or 100 bucks, whatever they're up to now, for one of these specialized wrenches. So there's a couple different ways we could go with the design on this. We could notch the end of the pipe and then design the plug with, basically a part on the outside that came out and went into that notch. And we could do maybe, 1, 2, 3 of them or 4 of them, whatever. I don't think I want to do that because while that would be really good at transferring the torque from the pipe to the plug here in the end, I think it's also going to substantially weaken the pipe, and we risk it cracking in the future. And even if we round those corners, we're still creating a stress point. And if we round the corners, we're potentially going to cause force that drives the plug out under rotational torque. So I think we'll stick with the original methodology of drilling holes in it and using fasteners. We'll just use better fasteners this time. Instead of like thin steel nails, we'll do, I don't know, something stainless steel, because we can't have anything protruding from the edge of the pipe. So I got to think about that. So, all right, I'm going to get some measurements of this. I do like the overall length of it. I'm not going to reuse this pipe because this one's already been drilled in this end and drilled in this end, and I do want to keep the overall length of this one. So I'm going to go up in the barn and see if I have any more of this PVC. I think this is 2-inch. Yeah, this is 2-inch inside diameter PVC pipe. So I'm going to go see if I have some more of this. I'll bring you guys back. All right, as luck would have it, I do actually have another piece of this 2-inch pipe. It is not quite the same pipe. It's like it's not from the same piece of pipe, but I think the specs on this stuff are pretty standard. So I'm going to take some measurements of everything we're working with here. I think this is 1.25 inches. Yeah, this is 1.25 inch square drive. So I'm going to get the measurements of the inside diameter of the pipe, the outside diameter of the pipe, and I'm going to start drawing, and I'll bring you guys back. All right, and here is the design that I came up with for these pieces. And the whole thing is basically designed around using stainless steel M5 set screws to secure everything together. So starting with the handle, which I probably spent the most amount of time on, honestly. I really wanted this to be a lot more comfortable to use than the previous one that just had that bar of aluminum stock through it. This should be a lot more comfortable on the hands. And I maximized the size of this by, I'm planning on turning this to 45 degrees on the build plate, and I already calculated out what that is, and this is basically the maximum size I can make this to be able to print this on my Bamboo P1S or X1C. And this will be the face that gets printed down on the bed, so there's no overhangs or anything that should be a challenge to print here. And the slot for the pipe actually drops all the way down to the bottom of the handle so that I'm not counting on layer adhesion up here to hold this guy together. The pipe itself is actually going to drop all the way down to within a couple millimeters of this face down here. The holes are sized for M5 set screws, and they're actually a little bit undersized. And I did that so that I can use them as basically drill guides and the holes that get used for the set screws. So if we drill this with the drill bit that is the correct one for the tap size for M5, which is I think 4.2 millimeter, these are sized at 4 millimeter. So if we drill these with a 4.2 millimeter drill bit or something close to that, not only will these guide our drill bit in the right location, but they'll also get drilled out to the correct size for those set screws. And the set screws will pass through the outer barrel here and then go into the PVC pipe. So that's the handle. This piece here is actually just a drill guide for the other end of the pipe. This will slip over the outside of the pipe. And then this is our plug that goes into the end of the pipe that actually has our square drive in it. And this piece is just temporary. This is not going to stay on there. That is only going to be on there long enough just to mark the locations basically, or really act as a drill guide to drill the holes for the plug, because this is going to be inside the pipe. So once we slip this guy in, we won't actually see where these holes are. And same thing, these are all sized at 4 millimeter. So when I use this as a drill guide, I still know that I'll be on center versus that bit walking around in there. And as we drill into these, that'll drill these out to be the right size for those set screws. And I'm not actually going to tap these holes. All this material should be soft enough that I can just put those set screws right in and they will make their own threads as they go in. Put a little bevel down here on the bottom just to get this guy started in the pipe. This should be a nice snug slip fit in the end of the pipe. This should slip over the end of the pipe without issue, but stay in place. And this should be snug enough that it's not rocking around, but should slip over the pipe. All right, I'm gonna get these printing and I'll bring you guys back. All right, while we're waiting for those to print, there is something else I have to talk to you guys about because it is 100% going to impact the channel, and I might even need your help a little bit. By the time you guys watch this video, I will have had surgery on this arm. Pretty much my whole adult life, I've been dealing with pain in my wrist, and the older I get, the less useful it is. I'm not in terrible pain all the time. It's generally only when I do things that require like a lot of gripping and rotational force at the same time. So like the same force that you'd use, say, grabbing a screwdriver and driving a screw in. I have a lot of pain doing that type of work with this wrist, and it's not getting any better. And what's causing it is there's two bones in your arm. I don't remember what this one's called on the inside, but on the outside, that is your ulna. And those two bones come down to the wrist joint. And my ulna is longer than it should be. I think I broke this arm when I was quite young, and my guess is that the bone just, I don't know, maybe it just gained a little bit when it healed while I was growing. So because it's too long, it puts unreasonable pressure on this side of my wrist joint. It's supposed to be equal pressure, but because that bone's too long, all of the pressure ends up on this side of the wrist when I use it. So the fix is, yeah, I'm not going to get really gory with you, but they're actually going to have to cut that bone, take part of it out, and then stick it back together. They're also going to try and kind of clean up some of the damage to my wrist joint that's happened over time just from all that force on the one side. And I have like an entrapped nerve in my elbow as well. I understand that's fairly common, and that's a pretty easy procedure. But the bone is going to be a big deal. I am probably not going to have at least full use of this arm and this wrist for like 6 months, they're telling me, which is quite scary for someone that uses their hands a lot and is always messing with stuff. But you know, we're going to work around it. I'm still going to do videos every week, or at least I'm planning on doing videos every week. But I will certainly be limited by what I can do. You know, fortunately, I'll have good use of this hand, but I am right-handed, so my guess is I'm probably going to get quite a bit better with my left in the process of you know, the time I'm healing on this side. So what does that mean for the channel, and what do I mean by I might need your help? Well, from a help perspective, I'm probably just going to be looking for your opinion on what things you'd like to see me cover here on the channel, because we can certainly still do 3D printing projects. It's just going to be limited to things that are easier to draw, especially early in the recovery process when I probably won't have much use of this at all, and it's going to be really tough to draw with just one hand, because you know, generally you're using the keyboard and the mouse at the same time. But still, there's some simple projects that we can do, and some of the designs that I have in mind I think will still be reasonably easy to do and are not going to require assembly, or are going to require very basic assembly that I can do with one hand. I also have some ideas of other stuff to cover. Like, I've been thinking for a while about doing a video on how I tune my flow rate, how I tune pressure advance. There's 2 tricks there that I think would be great to share that I haven't seen anybody else do. And I also have a couple different stations of stuff set up to play with. Okay, so all the way down in this end of my shop, I've set up basically 2 play areas for myself. I know I'm not going to be able to lift stuff and move stuff around for a bit, so I figured I'd just clear off both these spaces and get these 2 machines set up so that I can continue to work with them. Because, you know, even if I can only use my left hand, it'll be slow going, but I should still be able to do pretty much everything that I would otherwise do with either one of these. You've seen this one on the channel before. This is the Monport GA30. I think we've done 3 projects with this at this point. Really happy with this machine. It's done a great job with everything that I have asked it to do, but I'm not done with it. I have a bunch more ideas of things that I want to do with this machine. This is a MOPA fiber laser, 30 watt. And I've got some more ideas that are 3D printing related, including just testing it on other materials and figuring out what settings work. And yeah, of course, I'll share all that with you guys. But there's some non-3D printing related stuff that are it's just related to making in general that I'd also like to try out on this machine. This other machine is the Xtool F1 Ultra, and I mentioned in a previous video that I had one of these, or I had one coming, but I hadn't actually set anything up yet. I've now physically set it all up, I've connected it all together, I've plugged it in, I turned it on, I made sure it works, but I didn't do anything else with it yet, and that was on purpose. I kind of saved this for myself, knowing that I'm going to be looking for things to do after the surgery, and yeah, even if I, you know, can only use one hand, I should still be able to do everything with this, just it might be a little bit more slow going. So I'm really looking forward to digging in and playing with this machine. This is also a fiber laser. It's also a diode laser. It's 2 different laser heads in one. So this one and this one are both fiber lasers. This one is a MOPA, so there's a lot more things you can do on the fiber laser side with this one. But this one has a bunch of tricks up its sleeve too. Like I said, it's actually got 2 different lasers in the head, diode and fiber. And there's a bunch of cool accessories with this too. There's actually a conveyor belt that goes on this thing. So stay tuned. We're going to be doing some cool stuff with the Xtool F1 Ultra in future videos as well. All right, parts are done. Let's see how we did. So the handle I printed in just plain old Bambu Lab PLA Basic because I want it to be nice and rigid, and I think this is already way overkill. I highly doubt we're going to break this part ever. Same thing for the slip ring that is just going to be used to mark where we're going to drill the holes on the outside of the pipe for the bottom part. But this I printed in the Bamboo Labs petg HF, the high flow stuff again. Same thing that I used for those post caps from, I think, 2 weeks back. And again, beautiful print quality, but I went with petg for this thinking that the toughness from it is going to be more important than the rigidity from PLA. Because we've got plenty of contact surface here. I'm not really worried about this, potentially flexing a little bit and moving out of place. I mean, there's no place for it to go. It's going to be trapped inside the pipe. So I think petg, the toughness that we get from petg is going to be the better choice for this part. All right, let's see how this guy actually fits. This should be a nice tight slip fit. And it is not even close. That is quite loose. I don't know if I wonder if I measured that wrong. Yeah, it's a nice fit in this one. I got lazy and I took this up to my desk and I just took all my measurements off this one rather than trying to take this 8-foot piece up there or write down all the measurements down here. I tend to just measure stuff at my desk when I can because it's easy. And yeah, it didn't work out so well this time because it's a little loose in this one too. Yeah, it's not bad, but yeah, it's definitely not a good fit in this one. So, all right, well, we're going to be reprinting this. I wonder if the outside diameter is different too. Okay, well, that's a good fit. So it seems like the OD is the same between those pipes. If anything, that's even tighter than it needs to be. Now this inner part is going to be the same diameter as this plug, but the OD of this should be the same size as this. So I bet this is fine. Yeah. Yeah, it's tightening up on there right away. I don't want to get it stuck. Okay, so I think our handle is good. Our slip ring for measuring should be good. I need to reprint this. So, all right, I'm going to go add maybe 0.3 millimeters to the OD of this, and I'll bring you guys back. All right, 2 seconds for you guys, 2 hours for me. Let's see if this guy fits. Oh yeah, that's actually a really good fit now. That's pretty much exactly the fit I was going for on this one, which we actually didn't even end up on the pipe that I had measured. So we probably would have been reprinting this piece anyway, but that is a really nice fit now. So all right, I guess I've got to now cut this pipe to length. So let's get this pipe cut down to the same length as this one, and let's start getting this together. All right, hopefully that is square enough. And I also hit the edges quick on the belt sander just to knock off the burrs. And we could actually take our plug that is too small, just get an idea of how square the end is. Yeah, that actually looks really good. Check the other end. That's why I cut both ends, by the way. You saw me trim just like the tiniest bit off the second end, and that was just to make sure it was nice and square. Yeah, looks pretty good. Okay, I think the first thing I want to put on is the handle. And we're going to press this on and then use these holes as drill guides. If you remember, I undersized these. These are going to be M5 set screws. The drill size for an M5 bolt is 4.2 millimeters. I sized these to 4 millimeters. So we should be able to basically use these as a drill guide and also drill these out to the correct size at the same time. But we've got to get this pressed on here first. So it's going to be tough to film. I'm going to see if I can just push down from the top of the pipe and force it down in there. You know what? I should probably mark the pipe because this goes, I don't know if you want to call that a bore, extends all the way down into, I think, all the way to 3 millimeters from this face. So yeah, let me mark the pipe to make sure that we're actually seated all the way in. Looks like we're right there by the D after ASTM, so just put it there. We know if we're reasonably close to that tape now that we are fully seated. All right, well, that was a nice snug fit. but I don't think anything is giving. I mean, it wasn't so tight that I was worried about this splitting, but it was definitely tight enough, you know, once we got past about that point that the friction was enough that we had to use the mallet. So, all right, well, we are seated all the way in there. Let's get this drilled out. And unfortunately, the correct set screws have not come yet. I've got regular steel ones, but the stainless steel ones haven't come. Yeah, this is the kit that I had. So I think what I'll do is we'll drill all the holes and I'll put just half of the set screws in. That way when the stainless steel ones come, I only have to swap out half of them and then put the rest in. All right, I don't think I have a 4.2 millimeter drill bit. I do have some metric drill bits, but I don't think I have a 4.2. But if we go to 4.2 on our calipers, we can just kind of really easily cheat here. Switch it back over to imperial. So 165.5. Let me see what I have close to that. Yeah, so look at that. In a numbered drill bit set, we have a 166. That is only half a thou off the recommended size. So that should be perfect. Just do an idiot check here, make sure. Yeah, 4.19. That is almost dead on what we want. If you missed it, I made this in a previous video, and this is probably one of the functional prints that I use more than any other one. This hex wrench rack is great. I'll link to this video down in the description. If you didn't see that video, go check it out. This is like, I grab this and use this all the time. All right, when I put that in, a little bit of material actually got pushed up as those threads got formed. That's going to drive me nuts. So I think I'm actually going to take that back out, hit that with the deburring tool. We'll try the same thing on this one. I'll deburr it first and see if we still have to pull it back out and deburr it. But I don't like the way that's sticking up. So you guys are probably familiar with this style of no-good deburring tool, and these are great. I use these in 3D printing all the time, but they're not great for these really small holes. No-good does make another style that rotates around like this with this type of head that's really great for these types of holes. Yeah, look at that. I probably even was more aggressive with that than I needed to be. I'll link this guy down in the description. All right, this side's going to be a little bit trickier because we have to basically line up the holes with this guy and our little sleeve here. And I would really like it if the actual square socket on the end of this was in alignment with the handle. All right, I don't think this is quite as bad as I thought. I used a long rule to basically transfer the position of the center point here down to this end. So now we've basically just got to line up that hole with that mark, which I think we can do with a strap wrench. Yeah, it looks pretty good. All right, everything should line up for our plug now. Now, let me get 2 punches so that we can just make sure everything lines up. Okay, so that is lined up. Okay, so now this punch should drop into each one of these holes. And yeah, that's dropping in. I think we're all the way around. Yep. All right, all these look good. So I'm going to drill one because the plug hasn't been drilled out to the correct tap size yet. We'll put that one in just to make sure that nothing moves, and then we'll drill the other ones. All right, guys, well, it wasn't without some trial and error, but we got there in the end. And I gotta say, this is so much nicer than the original one, particularly on the handle end. I mean, this was passable. You know, it hadn't broken in the years I've used it, but this handle is so much nicer. It is the right size to actually be able to grip around with your hands and hold on to it. And this end is going to be a lot more durable, particularly in the salt water that it gets exposed to. Yeah, I'm still waiting for those stainless steel set screws to pop in and replace these ones that I did put in place. And I think one more thing that I'm going to do when I do get the other set screws, I'm going to pull this plug back out and just put silicone or something around the outside of it before I slip it back in so that water can't seep up between this and the pipe and end up trapped in here. I don't think it would happen, but if it does, it'd probably end up in there for quite a while, and I really don't want water sloshing around in this thing. So if you're watching this video and you want to make one of these for yourself, the STLs for all these parts, as well as everything that I cover here on this channel, is available completely for free. They're on my site, fpfdesigns.com. That is linked down in the description of this video. And I'll link to all of the hardware and tools that I used to get everything together here today as well. Guys, as always, thanks for hanging out in the shop with me for this week's design and build. I really enjoyed designing and putting this together. Hopefully you guys enjoyed watching it as well. And if there's anything different that you would have done on this, feel free to let me know down in the comments. There's been some great discussions on previous videos about different ideas for ways to do stuff, and I always enjoy reading it. And if this is by chance your first time here on the channel, this is all we do. It's all functional stuff like this. There's no multicolored doodad of the week or minifigs or stuff like that. There's nothing wrong with that. It's just not the focus of this channel. So if you like that sort of thing, check out some of my other videos. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.